Good morning. Okay, so now we are in the discussion of what is SAP S/4HANA. Okay, so when you come to the SAP, so yesterday we discussed about the complete process till SAP Simple Finance, and now the new version of the new application has come into the picture in 2015. We call it as the SAP S/4HANA. See, when you go back, we are dealing with SAP ECC. When you go back till 2015, we are dealing only with SAP ECC, and the underlying database is going to be the SAP HANA. SAP HANA. But from the SAP HANA point of view, I'm very much satisfied about the database, which is very much improvement when comparing with my traditional database approaches. Yes, very good. I have a complete understanding about the SAP HANA and how it is going to be helpful for me. So how the real-time reporting and the real-time analytics, how the OLAP and OLTP are merged together. Now, what are the BW capabilities are inbuilt in SAP S/4HANA, and what are the advantages I'm going to be getting using SAP S/4HANA from the database point of view. So I'm okay. So every customer is very satisfied, and so that we have been migrated our database from SAP Oracle database or something like Oracle database to SAP HANA database. Now we are in SAP HANA database. But what happened to my application then? Still, we had to use the same core application as an SAP ECC. Why? Because there are some disadvantages are there. If I go with SAP ECC application, normally when you go back to your SAP ECC application, I'm talking about the two important major things today. One is going to be calling it as very, very important. Two major important. One is simplified. Very, very important. Simplified application code. Now we are talking because we are doing the simplification. Okay, simplified application core. Okay, simplified application code and the simplified application code data. We can call it as a code data or data core here. Now we are talking more about, so let me remove this. Okay, I'll be explaining. Okay, don't worry about that. Okay, now we are talking about from the application. Yes, database, we have done it. Now we have to switch on to the application. When you go back to your SAP ECC, okay, so SAP ECC, we are going to build any application. For example, you are going to build any logic for any kind of reporting or any kind of enhancement. Normally, what you will do here, so normally, this is what exactly my application. Okay, so below, okay, we have to extract the database from the data from the database table, because data will be resided in the database table itself only. So whenever you want to develop a new report or something like enhancement, so normally you will fetch the data from the database table only. This is what exactly I'm going to be doing. So this is my database table. So we have example, I'm taking two database table. This is my database table, very, very important here. So I'm writing here database tables, DB tables. Actually, I'll write as a DB tables. So I had to, now today I need to develop a new report or something like a new enhancement or new transaction, whatever it may be. Now what exactly we'll do, this is completely, we call it as the application core. This box, okay, the big box, okay, we are going to be calling it as an application core. So what my technical people will do, the technical people, the technical means you call them as a technical ABAPers. We call them as a ABAPers. So when they are writing the coding, when they are inserting the coding to particular projects, okay. So I'll remove this one. Okay, so they are going to build additional okay, very, very important. So here and here, additional DB objects. DB means database objects. DB objects for improve the performance, for improve performance. Additional Okay, so I'm going to be using something called as the additional, okay, additional logic or something like additional logic to improve, or otherwise I can write here. Okay. Now, if you see this diagram here, so I'm going to be explaining you more important about what exactly the meaning of this simplification. If you see here, what exactly the meaning of simplification, what happened to me? Okay, let it be. Now, what exactly the meaning of simplification? Here, this diagram is going to explain you more about the detailed explanation. Now, very, very important diagram. This is going to be playing the major role. This is very, very important diagram. Now, if you see here, I'm going to be building the aggregates. Now we are talking about the simplification from the application point of view. So later we have the simplification on the database. So today we are going to be talking more on the application point of view here. Now, when you go for your traditional application means I'm talking on ECC. When we are talking only on ECC, okay? So your traditional application was built into more complex way, mean to say that 70% of the programming, 70% of the logic, what you are going to be writing, it is only for the improvement of the performance only. See, very, very important. 70% of the logic, 70 to 80% of the logic you are writing on the database table to only for the performance. So for nothing but you're writing an additional code needed to improve the performance, and you're writing some additional DB objects needed for your performance. Means, so when you want to extract the data from the database tables, so on the top of your database tables, you are going to develop some aggregates. Means you are aggregating the data. You are aggregating the data on the top of your database tables. Means your application coding has been written in such a way that on the database table, some aggregates are going to be written. Why? Because, so if I'm not going to write some aggregates on the database table, so what is happening to extract the data from the database table, the performance is going to be very, very high. So I can see sometimes and something called as a runtime error. Runtime error is nothing but that logic, the query which you have been sent to the database table is not going to be extracting the data from the database table. So here, when you come here, the system has been very good explanation here. The traditional application were built on the hierarchy data model. This is what exactly we call it as a hierarchy. The orange color one. The hierarchy is going to be built on here. What is this hierarchy? Hierarchy is nothing but on the database tables. So we are going to build some aggregate tables, and to improve the again the performance, again we are writing some aggregates on the database tables, and in middle we are inserting some indexes. What are these indexes? Indexes are nothing but to improve the speed. Indexes are nothing but to improve the speed of the performance. So here, traditional applications were built on the hierarchical data model. Detailed data was summarized. So detailed data was summarized into the higher level of your aggregate to help your system performance. So what is the detailed level? Detailed level is nothing but, okay, so I want a customer aging report. For example, I want a customer aging report. So the customer aging report, I want the details about the customer, who are the top 10 customers, what is the total aging, the days of the aging, and what is the total amount which I had to receive, and what is the total amount where what they have been made a payment. So I want a complete called as a detailed aggregation report from their side of you, okay, which we call it as a customer aging report. I want to have a total outstanding balances from the customer, and within how many days they are going to make the payment to me, and what are all the payments they have done as on date, and what is the remaining amount, and till how many days the payment is pending. So I want a complete detailed aggregation report over here. So if you want to get that kind of report, normally what we will do, we will fetch the data from the database tables. Normally, so data will be resided in the database tables. Normally, if you go to the SAP HANA as a database, so the tables are resided over there. Now, I will get the data. I will get all the data from the database tables. As you go back to my previous classes, I told that the query will be extracting from each and every processor of each and every database table. Now, what is happening once you fetch the data from the database table? So what is happening? The aggregation has to be done at the application level. Normally, what has to do the system, the database has to do the compiling. But here the database is not going to do any kind of compilation. So what is happening? The logic of the extracting the data will be moved to your application. What my technical people are going to do then? They're going to write some additional code. They're going to write some additional code. Why? Because if I compile the data in my application, if I do the compiling of the data in my application, it will take a long period of time. I mean to say it will take up to 30 minutes, 40 minutes, even though it will take up to 1 year also. Extremely sorry, 1 hour also. So what is happening? If the application needed more time to compile the data, so definitely the burden means the burden on my application is going to be more. So I don't want to keep the burden on my application. So what my technical people are doing, so the in between these performance, so they're going to add some aggregates in the logic. Aggregates, what these aggregations will do, these aggregates will compile the data at the higher level of your database table. Means the first layer of the data will be going to do the aggregation of the data. So what is happening? My technical people, they're going to write some additional code which is needed to your performance. So here, when you come here, so the detailed data was summarized into the higher layer of aggregate to help the system performance. On the top of aggregates, we built more aggregates and special versions of the database table to support the special applications. So on the top of your aggregates, again, I'm going to add some more aggregates to improve my performance. Why? Because I can't compile the data in the database. The data compilation has to be done at my application level itself only. I cannot do at my database level. So database level. So what is happening here? So we see something extra copies of the data, and we also built a application code to maintain the extra tables and keep them up to date. Yes, my application people, they're going to write some extra code. That is nothing but they're going to build on hierarchies. And what is happening? I'm telling the 70% of your coding is only for the performance only. 70% of the logic which you are going to be building to this customer aging report means the 70% of the logic you're only using for the application performance only. And the remaining 30% only the actual coding you're going to be writing to extract the data from your database tables. Only 30% of the coding is helpful for you. Remaining 70% I'm using only for the performance. Very, very important. So database indexes will improve the speed, and because they are based on the common access path of the data. Yes, very, very important. As I told you that in each and every application, okay, so in each and every aggregates, I'm going to build some indexes. Why? Because I had to make it at the speed, so the performance has to increase. So what I'm going to do, additional DB objects needed to improve the performance. These are going to be called as additional DB objects. Yes. And these aggregates are going to be calling it as additional coding, which I'm going to be writing to improve the performance. So these index tables, so in between each and every aggregates, I'm including some indexes. Why? Because to improve the performance, to speed up the performance. Normally we call it as the speed of the performance based on the application, but they are only consistently dropped and rebuilt each time the database tables are updated. So what is happening? So mean to say that my application was only to build on only the 30%, because whatever the remaining 70% I'm going to be building is only for the performance only. Now, in my SAP S4HANA, which we call it as a next generation business suite. Now we are going to be calling SAP S4HANA. Now we are going to be talking about the new thing which is going to be approaching. Now we are talking about SAP S4HANA. SAP S4HANA is nothing but your core application. Now from today onwards, we are going to be using SAP S4HANA, which is a new application process on the underlying database of your SAP HANA. So now I'm bringing the next generation business suite, which we call it as the next generation business suite, which is fully built on in-memory database application platform, which has been introduced in the year of 2015. My dear friends, 2015 is the year where I have brought a new generation business suite called as SAP S4HANA, and it has been released with two versions. One is with SAP S4HANA Cloud and SAP S4HANA On-Premise. SAP S4HANA Cloud, and we are going to be talking about SAP S4HANA On-Premise. It has came out with two versions. With cloud and with on-premise. So The version which has been released in the year of 2015 is called as the application version. The S4 HANA core version has been released in the version year. The release version is going to be called as 1511. 1511 is the first SAP S4HANA core version release for both SAP S4HANA on-premise and SAP S4HANA cloud. 15 is the year, 15 is the year, and 11 is the month of November. So in the month of November 2015, in the month of November 2015, we came out with a new application process called as SAP S4HANA. Very, very important, very important, with a core application of 100. 100 is the core application. So what is the importance? What is the difference we have been brought from your ECC to SAP S4HANA? Now, whatever the aggregates we are going to be talking, whatever the aggregates parts we are going to be talking, the layer of application, whatever the aggregates we are going to be talking. Now, from today onwards, you are going to get all the aggregations on the fly within fraction of seconds. You will get all the data, you'll get all the detailed data on the fly. Means the detailed data is going to be aggregated on the fly. Means I don't require any kind of this aggregation and the indexes for my SAP S4HANA. So what is happening, the unwanted 70% of your code application, whatever the logic you have been built to improve the performance, now I don't require this kind of aggregation and the indexes from today onwards on my SAP S4HANA from. Very important. Now, the speed, you're talking about the speed, nothing to be worried about the speed. Why? Because I'm bringing the in-memory concept with the columnar storage. Now, what the SAP is telling here is nothing but using the raw power of SAP HANA. SAP HANA is nothing but, we call it as a database. SAP HANA is nothing but, you call it as a database. So using the raw power of SAP HANA, we can aggregate on the fly in sub-second from any line item level table. Now today we have a new line item level table called as ACDOCA table. Very important, my dear friends. So today onwards, so you can get all the data on the fly in sub-seconds because I have the concept of in-memory. So your CPU is very near to in-memory. So you can build up. So whatever the data you are going to be extracting, I'll get all the data from your in-memory from your database. No need to build any kind of logic on your application. So the extra logic which you have been written, now that is not going to be the required. So what is happening in this addition to the losing of the aggregates and the indexes from the database table. So from the database table, I'm not going to trigger any kind of aggregates and the indexes from today. So you're losing these aggregates and the indexes. So we can remove the huge amount of application code. I don't require this application code from today onwards. Why? Because earlier my application has to do the compiling, not the database. But today my database is compiling the report on the fly. You will get all the data in a sub-seconds, my dear friends, as a detailed report from the line item level report. Okay, so I don't need to write any kind of application code to improve the performance based on the aggregation. So we are left out with the simplified. That's what exactly we call it as. We are with simplified code data model, and we are on simplified application code. What is the core data? Simplified core data is nothing but your database, and simplified core application code is nothing but your application from today. So everything has been simplified, not only from your database level, from the application point of view also. I have done the simplification, means I have removed all this kind of indexes and the aggregations from the database tables. Now you can call me one question to me. Okay, Raj. Okay, Rahul. You are telling that now from today onwards, you are building a new application called as S4HANA, now where we are not going to be required with any kind of aggregations and the indexes. Very good. Now let me come out with one point. Now I started my journey with SAP ECC. Let us assume that I started my SAP ECC with 6.1 in 2012. I started the journey with SAP ECC. Now there are so many reports are there. I built so many reports. Means in SAP ECC, I built so many custom reports. I'm not talking about the standard reports. Forget about the standard reports. I have built so many reports based on my ECC. There are so many Z reports. We can call them as the Z reports, which are fully built on this, whatever you're talking the aggregates and the indexes only. You're talking about which all index. See, whatever the aggregations you are talking, whatever the indexes you are talking, my logic was built on this aggregation and indexes only. Now you are telling that in SAP S4 HANA. Now just now you told that in SAP S4 HANA, when you take this SAP S4 HANA, now you are telling that these indexes and aggregations are not going to be required here. In the indexes and aggregations are not going to be required in your SAP S4 HANA. Now SAP is very clear in making me the statement that when you go for an on-premise, your ECC core application can be converted to SAP S4 HANA, which is called as a conversion. I call it as a conversion. Means a customer can start his journey with SAP S4 HANA, an existing customer, I'm talking about the existing customer, he can start the journey with SAP S4 HANA, where he can do the conversion from ECC to SAP. So conversion is not possible in SAP clouds. No conversion can be done in the cloud. Conversion can be only possible on SAP S4 HANA on-premise from ECC to SAP S4 HANA. During this conversion, just now you're telling that. Now, whatever these aggregations and the indexes you're talking, just now you're talking about the aggregation and the indexes. Okay, I'll take out these indexes and the aggregation. Now you're telling that these indexes and the aggregations are no more required in SAP S4 HANA. Very good. I'm totally accepting this. Now, when I'm doing the system conversion from SAP ECC to SAP S4 HANA, so what happened to my Z reports? I'm not talking about the standard. I'm talking only the custom reports I have developed based on the business requirement. The most of the custom, there are nearly about 100 reports are there, maybe 30, 40, 50 or whatever may be the count here. We have maximum number of custom Z reports are there, which my technical people have been built based on this aggregation and the index tables only. Now, when I move from ECC to SAP S4 HANA, all these Z reports are not going to be available in SAP S4 HANA. And I will not be executing these reports in SAP S4 HANA, so that I need to build a new logic in SAP S4 HANA for all these 50 reports, whatever the 50 Z reports you're going to be talking. Because all these 50 reports have been built on the logic of this aggregation and the indexes only. Now you're talking that now these aggregation and indexes tables are no more available in SAP S4 HANA. All these aggregation and index tables are removed. Mean to say that if I come to the PPT, if I come to my PPT here, you're telling that, okay, these are the tables are no more available in SAP S4 HANA. Where are these tables? Yeah, these are the tables. Now you're talking about these are the tables are no more available. All these index tables and aggregation tables are no more available. These have been removed. But my previous logic, whatever the 50 reports you're talking, the previous logic has been written on the same application based on these indexes and aggregates tables only. Now, what do you want to say here? What do you want to say? So I need to build all these 50 reports in SAP S4 HANA? No, not required. All these 50 reports, whatever the 50 reports you're going to be talking, all these 50 reports you can use in SAP S4 HANA as it is only. No need to require any kind of reporting. No, but before that, before you do the system conversion from SAP ECC to SAP S4 HANA. So as a prerequisite, one of the prerequisite, there is a custom code analyzing tool. I'm going to be giving you one tool called as custom code analyzer. So I'll be giving you one tool called as custom code analyzer. So you have to run this custom code analyzer in your SAP ECC. Very, very important. It is one of the prerequisite before you do the system conversion from SAP ECC to SAP S4 HANA. So this custom code analyzer, what it will do, it will be loaded with all the simplification items. You can download all the, whatever all the simplifications have been done in SAP S4 HANA, you can get all the simplifications from your service marketplace. So you are going to load all the simplifications in this custom code analyzer, and you have to execute this analyzer in your SAP ECC. So it will take some time, about 30 to 40 minutes, and it will come out with one output. It will come out with an output data. It will come out with an output data. In this output, it will very clearly tell that out of 50 reports, 30 reports are fine, 30 reports are built on the new logic of your SAP S4 HANA, means whatever the aggregations and indexations you have written, these are not available for this 30 reports, and the remaining 20 reports you're talking, the 20 reports you had to do some modifications. You had to do some changes in the coding. Until or unless if you're not doing this coding for these 20 reports, until or unless if you're not changing, if you're not doing the changes in the coding in so and so line, these 20 reports cannot be migrated, or 20 reports cannot be seen in your SAP S4HANA. Okay, 30 reports are fine as per the new logic. Okay, so it is compatible between SAP ECC to SAP S4HANA, but only the problem with 20 reports. You had to change some coding before you go to the conversion from ECC to SAP S4HANA. So this custom code analyzer, what it is going to do, it will run the reports. It will run all the custom reports and the standard reports, and it will give an output, which are all the reports are affected, which are all the reports are affected during the conversion from ECC to SAP S4HANA. Now my technical people have to take a chance. So now they have to sit along with the business users, and they have to explain why these 20 reports has to do the changes. If we do the changes, is this going to be impacting to my normal business process? No. If it is not impacting, do the changes as per the new SAP S4HANA application process. Once you do the changes, once you have completed all the changes as per the custom code analyzer, now again I have to re-execute this custom code analyzer once again, and make sure that all these 50 reports, what you are going to be talking, are compatible. Now I can do the conversion from SAP ECC to SAP S4HANA. Okay, very good. So understand that. Okay, now very good, Rahul. Okay, so you're telling that. Okay, so these all 50 reports are available now. Okay, now as per the new SAP S4HANA logic. But just now you told Rahul that this aggregate and index tables are no more available. You have shown me the slide also. You have shown me the slide also. Okay, let it be the compatible. Let it be all the 50 reports are going to be available in your SAP S4HANA. But just now you told that these all the tables, whatever the index tables and the aggregate tables you're talking, these tables are no more available in SAP S4HANA. But how these Z reports will work for me? Tell me now. How these 50 reports will work for me in SAP S4HANA if you don't have these aggregates and the index tables? Very, very important. So here SAP is telling that, very, very important here. The SAP is telling that I am using the concept called as redirect and range. Very, very important. Redirect and range. So here, once your 50 reports means once you all the Z reports have been converted to the new SAP S4HANA, automatically in the backend, no need to do. So the system is going to do the HANAtization. That is nothing but the system will insert a new logic called as redirect and read logic will be written in the backend. No need to write anything. Automatically the system will do this kind of portion. So redirect and read. What is this redirect and read? Now I'll tell you one example. This is called as a non-disruptiveness process. Actually, we call it as a non-disruptiveness process. Okay, I'll take this slide and I'll also explain on the board also. Don't worry about that. So whatever the custom core program or the custom report you have been executing in SAP S4HANA means earlier, I'll tell you one example now. I'll take you with one example now. Now, there is a one report called as customer aging analysis. Okay. Okay. There is a report called as customer aging report. This customer aging report has been developed. Okay, has been developed using of underlying database tables and the aggregate tables. Now you are fetching the data from, okay, so you are fetching same, I'll take the same data. Okay, so not to make it confused, so I'll take the same data. So these are the index tables and these are the aggregate tables. Okay, so I written the logic based on the index tables. Okay, one is going to be called as BSID, BSIS, BSAD, okay, BSAS, and I written based on the BKPF and written the basic on BSEG. Very, very important. Very, very important. Now, out of this, okay, and also I have written something called as Flagl-Flexty. F-A-G-L-F-L-E-X-T. This is the total table. Actually, we call it as aggregate table actually. Okay. Now, if you take back, okay, now I'll just move this. Okay. So I'll move the cursor here. I'll just copy these two and I'll put it on here. I'll just let me take it. Okay. I'll put it on here. Okay. So one is BKPF, another one is the BSEC. Normally, if you see here, these two are the database tables. These two are going to be calling it as the database tables. Normally, you see here, these two are going to be called as the data is going to be fetched from these database tables, and these are going to be calling as aggregates and the index tables. These are going to be calling them as aggregates and the index tables. Very, very important. Now, on the top of your database tables, so I have developed so many aggregates. So if you see here, I had developed so many aggregates on the top of your database tables, and on the layer of one more aggregates, again I had developed some more aggregates, and in between what I have done here is nothing but in between I have developed some indexes also. In between I have developed some indexes also now. Okay. These are going to be called. So these are going to be called as index and the aggregate tables. You can see here index and the aggregate tables. Now, based on this, I developed the logic, and this logic is going to be built for the customer aging report. And why I have developed all this kind of aggregation to improve my customer, to optimize my customer application, to optimize my custom code application programming. Now, very good. The report is executing very good. I am getting all the data now. Now, when you are migrating the same thing, when you have converted the same report to my SAP S4HANA, this is in SAP ECC. Now, what I'm telling here in my SAP S4HANA, when the underlying database is going to be your SAP HANA, because you will fetch the data from your database only. Normally, you will get all the data from your database tables only. Now, what is happening now? Today, we don't have these indexes and the aggregations. Now, nothing is going to be required. Now, today, we don't have these indexes and the aggregations. Very, very important. But still, I can execute this report in my SAP S4HANA. How? Because of non-disruptiveness process. We call it as a non-disruptiveness process with read and with redirecting and with reading capability. With redirecting and reading the capability. Now, see here. First, this is in my SAP S4HANA, my dear friends. This is in my SAP S4HANA I'm talking. Your custom report or the custom program, whatever, the customer aging report you're talking here. So once you have executed this report, so what it will do, the select statement. Every process will have the select statement. The select statement, what exactly it will do, it will go and look out for all these aggregate and the index tables like this. Okay, so it will go first because you have written the logic based on the aggregates and the indexes only. So first, your custom report, what it will do, it will try to go and look out for these tables. Very, very important. But these tables are not available, but these tables are no more available in your SAP S4HANA. Now in SAP S4HANA, these tables are no more available in your SAP S4HANA. So automatically system, what it will do, it will redirect. It will redirect automatically. Yes, these tables are no more available. So in the back end, automatically the statement, no need to do any kind of changes in the programming. Automatically the system itself, it will redirect to the compatibility view. Means what I want to say here, whatever the tables, which are all the tables which are no more available, which are not going to be, so they have been moved as a compatibility view tables. Now the data will be there, but the data will be there in compatibility view tables. Means if I go to the BSID table, if I go to the BSID table in SAP S4HANA, the technical logic of the BSID will not be available. No, the BSID table will not be available. So the BSID table has been moved as a compatibility. How it is going to look like now? V underscore BSID. Now the table look like this. V is nothing but view table. V is nothing but a view table. Now the system, what it will do, it will go and redirect to the compatibility view table. Data is there in this table, but the data will be there in this view table. So you want only the data. The system will go and read the data from this compatibility view table. Very well. You cannot delete, you cannot modify, you cannot change, or you cannot do any kind of changes over here. Means you can only read the data from the compatibility view. Now all the tables which have been removed, all the aggregates and the indexes tables, now these tables have been moved as a compatibility view table. So this compatibility view table will read the data from where. Now the data will be available in my SAP S4HANA, especially I'm talking in my SAP S4HANA. Your underlying database tables are much more available. Means these two tables are not removed because these are underlying database tables. Only these aggregate tables and the indexes tables are no more available. So if I want to read the data, so what the SAP is telling now, all the tables will read the data from these tables from today onwards. So the underlying is going to be this table. Now you will get all the data from this table. You will get all the data from this table. You will get all the data. This is the header table. Actually, I'm not going to touch this header table. Now, all the data is going to be available in the BSEC. So what my technical people are going to do, the logic or the standard logic, what it is going to be telling, first it will go and look for this table. First, it will go and look for this table. This table is no more available. So automatically, the statement, what it will do, it will redirect to this particular table. It is a view table, but it is only the view table. So now this view table, what it will do, it is available. So the view table data is available where? In the BSEC table. Now automatically system, what it will do, the view table is directed to your BSEC table, and this data, whatever the data you are residing, whatever the data you're looking from this BSID, this data will be read from where? This data will be read from this table. That is called as a read, R-E-A-D, read from where? This data will be read from your BSEC table. Now automatically what is happening? Your logic is not changed. Means your customer aging report is going to work as it is in my SAP S4HANA, but only one change is nothing but instead of getting the data from the BSID, the BSID table will read the data from the BSEC. The underlying table is going to be, now all the data of your BSID will be available in the BSEC table. Now your statement will read the data from here. So if I go into the SAP, okay, that there is some server issue, remote desktop, it is not working, but not to worry. Okay, let me give some time. Okay, so now what is happening here? So the BSID table, which we are going to be calling it as a normal index table. Now this normal index table is no more available in SAP S4HANA. So we can see the same table as a compatibility view table, as a view table. So view table means the data is there, but the data is resided in the view table. You can only read the data from this particular table. Okay, now where is this data? This data will be on the top of your BSEC table. Now when the logic is executed, now what is happening here? Now it will redirect to the compatibility view. So the compatibility view tables will read the data from where? The compatibility view table will read the data from the new table called as AC docker. Here they have given it as the ACDOCA table. Universal General Entry Table is nothing but ACDOCA table. Or normally in this logic, the data will be read from which table? The data will be read from the BSEC table. So what is happening? I'm not going to do any kind of logic change. The logic change is only nothing but I'm redirecting and reading the data from the underlying database table. So what is I'm telling here? So from today onwards, I don't need to require any kind of aggregates and the indexes on top of your database table. Why? Because I will read all the data from this particular tables only from today onwards. I will read all the data from this particular table and I'll fetch the data, and whatever the aggregates indexes you're talking, anyhow these aggregates and indexes data, I'm moving it at the compatibility view and I will redirect and read the data from this underlying database table. So this concept is called as non-disruptive nest process in SAP S4HANA. So means your previous Z tables and the Z programs, what you have written based on the aggregates and indexes, will work as it is in your SAP S4HANA, but the logic here is nothing but I am redirecting and reading the data. These compatibility view tables will read the data from where? It will read the data from your underlying database tables. Clear to all of you?
Yes,
Any
sir.
questions, please?
Yes, I do have a question, Rahul.
Yes.
So what if there are custom fields?
What happened? The custom fields. See, anyhow, the custom fields you have been inserting on your database. So now, whatever the custom fields you have written. So, for example, good question, sir. Now, for example, okay, here we are talking about the custom tables or something like that. But now, when I come to the custom fields, something like okay, Z underscore area. This is one of the custom field. Now, my AC Docker table, whatever the table you are going to be talking, universal general entry table now. Okay, this AC Docker table. Just I remove this. Now, this table is a very big table. So normally you can see nearly about 400, more than 400 fields are available. Standard fields are available in this particular table. But you can extend this table. You can extend this table more than 600 fields where all these custom fields can be means there is a custom code optimizer. We can call it as a you can optimize, means you can bring these custom fields, whatever the custom fields you have written, these custom fields I can also insert in my universal general entry table as one of the fields over here. Clear?
Yes, thanks, Rahul.
See here. This is my universal general entry table. So here you can see the coding block. Okay, here you can see it as the coding block. So where all the custom codes, means all the customer fields, whatever the fields you are going to be looking over here. So this universal general entry table will contain the fields of your general ledger, profitability analysis, material management accounting, that is asset accounting, and the material ledger. Now I'm making as a simplified that all these tables or all the index and aggregate tables are removed. Now you have only one table called as ACDOCA table. Now whatever the custom fields which are available over here, for example, there is a custom fields are available. Now those custom fields I can also insert in my AC Docker table. So you can see that more customer fields are going to be available by using of the coding block.
No need to do. A question on that? No. I do. I mean, it's actually clear, but I do have a question.
Yeah.
But can we? So if there are like custom tables itself, can we migrate those custom tables to this to the HANA, or will once I migrate?
Sir, you can. That's what I'm telling. Now you can migrate whatever the custom table you see. For example, that's what I'm telling. Not only custom fields, you have a new table called as underscore Z table. Yes, that table will be migrated to your SAP HANA. But in that custom table, if you have written the custom table based on the logic of your index and your aggregates, then it will be applicable as a redirect and read the concept.
Perfect. Thank you. Now it's clear. Thank you.